This is LeetCode 383 Ransom Note. So given two strings, Ransom Note and magazine, return true if Ransom Note can be constructed by using the letters from magazine and false otherwise. Each letter in magazine can only be used once in Ransom Note. We're given a few examples and then some constraints too. So pay close attention to this one. It's going to be important later. So Ransom Note and magazine consist of lowercase English letters. So let's take a look at example 1, and I've reproduced it right here. Ransom Note is A, magazine is B. So if we look at our Ransom Note, we want an A. Do we have one available to use in magazine? No, so we return false. Example 2, Ransom Note is AA this time, and then for magazine, we have A and we have B. So this is the setup for example 2. We want an A. Do we have one available? Yes. So I'll mark this as used by moving it over. And we're doing that because each letter in magazine can only be used once in Ransom Note. Next letter in Ransom Note we want is another A. Do we have another A available in magazine? Clearly no, we just have a B. So we return false for example 2. Okay, last example. Our Ransom Note is the same. It's AA. And then for magazine, we have A, AB. So this is the setup for example 3. We want an A. Do we have one available? Yes. I'll move it over. We want another A. Do we have one available? Yes. So I'll move it over. And then we've completed our Ransom Note and we can return true. So the question we're repeatedly asking is, for each letter in Ransom Note, is there one available in magazine? And so examining the letters in Ransom Note is easy. We can just iterate over the letters. But how do we structure the data for magazine? Well, the two key pieces of information are what letters we have in magazine and how many of those letters are available. And if I think through the common data structures, I realize that this is a perfect fit for a map. The keys can be the letters and the values can be how many of those letters are available. And then to mark a letter as used, we can just decrement the value by 1. Let's try implementing this idea. Okay, so I'm realizing that if Ransom Note is bigger, even by a single letter, then we won't even have enough letters to form Ransom Note, and so we can return false. So if the length of Ransom Note is bigger than the length of magazine, then we can return false. Now I want to create our magazine map. So I'll use Python's counter. It will create a map where the letters are the keys and the counts are the values. So from collections, import counter, and then we can use it below. So I'll call it magazine counts, and it'll be equal to counter, and we'll pass in our magazine string. And then for each letter we need in Ransom Note, so for letter needed in Ransom Note, we want to see if there's one available in magazine. So if magazine counts letter needed is greater than 0, which means we have one available, then we want to decrement that value. So I'll copy this over and then we'll decrement that by 1. And then if we don't have that available, then we can return false. And then finally, if we have everything we need, then we can return true. So I'll submit and we can see we have a working solution. Now I want to think about the time complexity. Because we have this length check at the top, we'll only continue if magazine is bigger than or equal to Ransom Note. So I'll keep that in mind. And then here we build the map for magazine. That will take O of magazine length time. And then here we also iterate over Ransom Note. So now we're at O of magazine length plus Ransom Note length. So now let's go back and think about that length check at the top. Since magazine length is greater than or equal to Ransom Note length, we can drop Ransom Note length. And so this becomes O of magazine length in its simplified form. And then space complexity can be a little bit tricky because we have to make sure we factor in all of the information in the problem. So it seems like it will be O of magazine length because we're creating a new map for magazine. But then we have to consider the constraint that we're only going to have lowercase English letters. So that means our map can only have up to 26 keys, which would simplify to O of 1 space. For time, we can't do better than O of magazine length because we have to iterate through the entire magazine to see if we have what we need. But are there any other approaches? So in our first approach, we took each individual letter in Ransom Note, and then we checked to see if we had that available in magazine. But we could just as easily step back and ask that same question at a broader level. So instead of thinking about each letter individually, we could zoom out and think about the entire string. So let me illustrate with an example. So instead of saying, I want an A, do we have an A available? We could modify that slightly and say, overall, for the entire Ransom Note, we need 2 A's. Are there at least 2 A's available in magazine? And to do this, we could create a map for Ransom Note as well, where the keys would be the letters and the values would be how much of that letter we need. So in this case, we would have A and the value would be 2. And then we could compare the two maps and just make sure that we have enough of each letter overall. Let's try and implement this idea. So first we'll do our length check again. So if the length of Ransom Note is bigger than the length of magazine, that means we can return false because we won't even have enough letters to form our note. And then I want to create maps for both Ransom Note and magazine, and I'll use Python's counter again. So from collections, import counter, and then we can use that below. So ransom counts will be equal to counter, and then we'll pass in our Ransom Note. And then magazine counts will be equal to counter, except we'll pass in magazine. And then we get to the heart of the problem. So for letter in ransom counts, we want to know if what we need is more than what we have. So if ransom counts letter is bigger than magazine counts letter, that means that what we need to form our note is bigger than what we have available. So there's no way we can form the note, and we can return false. And then finally, if we have everything we need, then we can return true at the end, and then we can submit. The time complexity is the same. It's O of magazine length, and we'll iterate over both Ransom Note and magazine in order to build these two maps. But we can drop the Ransom Note length because of the length check right here. So it's exactly the same reasoning as before. The space complexity is also the same, and this can be a little bit surprising. Yes, we're creating two maps, but remember the constraint that we can only have up to 26 keys in each of the maps because of the lowercase English letters. And so we still have O of 1 space, even though we're using an extra map. The first approach does have slightly better performance, but not in a way that's reflected in big O, so it shouldn't matter much in most cases. And then they're both very clear and easy to read, and so I don't think there's an obvious winner here. Both are reasonable approaches. Now, if you go back to the beginning, our line of reasoning started with asking, for each letter in Ransom Note, is there one available in magazine? And then we asked, how do we structure the data for magazine, which led us to our first map approach. After that, we asked ourselves, are there any other approaches, which led us to a closely related two-map approach, which ended up having the same big O time and space complexity. This is a great problem for learning about how to use maps effectively. And even though the approaches are very similar, seeing both of them is helpful because a lot of the techniques in both solutions come up all the time in different problems.